I'd like to welcome everyone. And so this morning session, I'm going to start with this slide. And this slide is shows the Hubble deep view of the space. And this is just a patch of the sky. And this is about 10 billion light years. That's the distance of these galaxies. So that means that the light that started in these galaxies started 10 billion years ago, and now we just see it now. So it takes 10 billion years for the light to get from these galaxies to us. As you see, now this one, for example, is a galaxy, this is a galaxy, and these are galaxies like ours. Milky Way is our galaxy, and it's 100,000 light years across. So that again, that means that it takes 100,000 years for the light to go from one end of the galaxy to the other end. We can't even imagine this, but look how small they look, this patch of the sky. And this is just one corner of the sky. It's absolutely amazing. So this is the opening statement of the Quran, and the meaning of it is, in the name of God, the All-Gracious, the All-Merciful. So that's how the Quran starts. Ultimate mathematics, generator of the scripture. So I'm going to give a visual presentation how this mathematics actually generates the Quran and the parameters of the Quran. And we'll see it, and this is our website here, godalone.org. And really the fundamentals of this mathematics is so complicated that we really don't know how to approach the mathematics. However, we see sort of a visual effects of these numbers that I'm going to present, and that visual effect of the numbers is what we can actually see, and what we can, it's a tangible way of looking at the Quran, and then we'll see how this whole thing has been generated and compiled. I've written a book called Ultimate Mathematics, and the introduction of it actually starts with a quotation from Johannes Kepler, and he was the one who actually came up with the idea of the planetary motion, Kepler's law. And the chief aim of all investigation of the external world should be to discover the rational order and harmony which has been imposed on it by God, and which he has revealed to us in the language of mathematics. So this man recognized that the entire universe is working based on mathematics. And he understood that that's the language that God speaks with mankind. And so this is 1571, 1630, so that's a long time ago, huh? All right. So ultimate mathematics. So this is an outline of my talk. I'm going to have an introduction, and then I'm going to talk about primes, composites, twin prime companions, Mersenne primes, Gaussian primes, semi-primes, and then indices. Okay? So this is really the first time that we are looking at primes, not only at primes, but they'll also look at the indices. That means the position of these primes in ascending order. Okay? And what those relations are and how they actually generate the Quran. So we're going to talk about group structures, how the group structures actually relate to these primes. And then number bases, again, how number bases connect to these primes, and twin primes, and so on. Then the second lecture after the intermission, I'm going to say and describe how these mathematics that we are discussing here is going to generate the scripture, which is the Quran. Okay, so prime numbers are numbers that are divisible by themselves and one only. Okay. So you cannot divide it by anything else. It's just by itself and one. So that's the definition of a prime number. So by this definition, 1 is not a prime number. Okay. So the first prime number is 2. So it is a formidable mathematical challenge to determine if a number is prime. That's by itself. Okay. So many algorithms have been developed to find new prime numbers. So it's a huge challenge. No exact theory exists linking linking primes to the positional rank of the index. For example, no one knows what the 1143rd prime is without working his or her way up to from the first prime to the 1143rd prime. So that's what you have to do. So if I ask anybody, okay, what is 1143rd prime? Nobody knows. So you have to write a program, okay? And then you write that program and tabulate all of these, and then you say, well, when I get to 1143, then I'll look across and see what that prime number is. So understanding prime would lead to appreciation of complexity of composites, twin primes, lonely primes, factorization of semi-primes and other number theory problems. Prime numbers, okay? So let's continue. Therefore, first we have to establish if a number is prime or not. That's the first order of business, okay? Forget about indices. First we have to do that. So I'm gonna take a very small number, 2747, which is a very small number. It's not a big number. And so let us see if this is prime or not. Well, we'll see it's not an even number, so it cannot be divisible by 2. Okay, so we'll reject that. Then we go to the next point and see if it's divisible by 3. So a number is divisible by 3 if the sum of its digits is divisible by 3. So we add them up. 2 plus 7 plus 4 plus 7 is 20. 20 is not divisible by 3, so it's not divisible by 3. So that's ruled out. So we keep trying. We go to the next one, which is 5, 7, 11, and so on. Okay? So we do this until we get to 41. So you see, you have to do some work here to get to 41, because 41 is the 13th prime. So you have to divide them by 12 primes previous to this one, previous to 41, below 41, and then all of a sudden you see, it's divisible by 41. So this number is actually 41 times 67. Okay? Then you say, it's not a prime. But you had to do a lot of work. Now imagine if this number was bigger, or you had a lot of them that you wanted to do this with. Okay. So now the next question is, are there infinitely many primes? So these are the mathematicians usually ask these questions. Okay? Can you prove that? And this proof actually was done, look at the date there, 325 to 365 BC. Okay? So you're talking about 2,400 years ago. Okay? So it says, so this was due to Euclid, and proved by contradiction that there are indeed infinitely many primes. And assume that you know the largest prime P. Then we can form a composite C such that C is equal to 2 times 3, all of the primes before that P, okay, the multiplication of all of those. Then we add 1 to it. Okay, that's how the proof goes. Then we add 1 to it. So C plus 1 is either a prime or not. If it is a prime, then it's obviously it's larger than P. So you can find always a number larger than P if this is a prime. If it is not a prime, then it cannot be divisible by any of these primes because we added 1 to it already. Okay? This is a beautiful proof, okay? So again, that number has to be larger than P. Okay. So that's how the proof goes. So prime index relation. So what is the relation between prime and its index or positional rank? Okay? As I said, 1143, for example. What is the 1143rd prime? So Gauss's prime number theorem relates a prime to its index through the following relation: I is equal to P divided by log of P. And the symbol Ln denotes the natural logarithm. And the above theorem was proven in the late 20th century. And so the above relation actually links the index to its corresponding prime in an asymptotic manner. It's just an approximation. Okay? And the index of the prime approaches the actual values as they tend to infinity. So it's asymptotic. It's not a one-to-one relation. So again, I want to emphasize here that there is no known relation, that unique relation that actually connects a prime to its index or positional rank. All right. So now we'll go to this. I'm going to tabulate some of these primes. Okay. And so I have 1, 2, 3, 4, 7. Okay. 2, 3, 17. 8 is 19. 9 is 23. 19 is 67. And we get to 1143, and we see it's 9221. Okay. So we had to write a program to do this. Without that, we can't do it. Okay. And 1187 is 9619. Okay. So what is a composite number now? So a composite number is a number that can be factored out into prime numbers. Okay. For example, 4 is a composite number because 4 is 2 times 2, or 2, 3, 4, 6 is a composite number. It's 2 times 3 times 17 times 23. And these are its prime factors. Okay. Factorization is a very complicated mathematical operation. It's not easy. Okay, and I'll discuss it in a minute. Okay, so we can again tabulate the composite using a computer program because what happens is that since you don't know a relation between prime and their indices, you are also unable to guess, for example, what is 3/68 composite without writing a program. There is no relation because you don't know the relation between primes and their indices, so you're also unable to do this for the composite. So they're just as complicated as the other. Okay? So if you remove all the primes, then you see that the first composite is 4, second one is 6, and then 127 is 166. Okay? All right. Now you can tabulate the prime and composite. As you see, that primes get bigger a lot faster than composites. So for example, the 19th prime is 67, and the 19th composite is 30. So that means there are a lot more composites than there are primes. Okay. So what are twin primes? Twin primes are a pair of prime numbers that differ by 2 in magnitude. So for example, 3 and 5 and 11 and 13 are twin primes. 4271 and 4273 are twin primes. Okay. So you see that only differ by 2. Okay. Now let's see how complicated things get. Okay, so again I tabulated these twin primes. As you see, the 19th twin prime is 281, 283, and 1/14th prime is 4271 and 4273. Okay, so now let's go to this one. Are there infinitely many twin primes? Let's see if we can prove this. Okay. So there are 2 related conjectures, each called the twin prime conjecture. Conjecture means to guess. So, the first version states that there are infinite numbers of pairs of twin primes. This is guide 1994, page 19. So, it is not known if there are an infinite number of such primes, Wells, 1986, Shanks, so on. Okay, so we can see that. But it seems almost certain to be true. Okay, so you guess at it. Okay, it's almost correct. The evidence, when they examine in detail, appears to justify the conjecture. So you just keep producing these with the computer, and you see, well, there's another pair, and so on. Okay. So now look at this one here. Okay. Arenstorff, 2004, published a purported proof that of the conjecture. Okay. Unfortunately, this shouldn't be unfortunately really, because there's no unfortunately. He was wrong or wrong. He was wrong, obviously. So a serious error was found in the proof. So as a result, the paper was retracted and twin prime conjecture remains fully open. So now can you imagine now, from 2300 BC till now, we cannot even go from 1 to 2. Okay? This is how complicated it is. You can't even prove that there are infinitely many twin primes. Forget about the relation between the twin primes and the indices. Okay? Alright, so here again we can do the twin prime sequentially, and you see the 19th one is 109, and I keep referring to 19, and it becomes clear in the second after the intermission why this is, I highlight this. And then you can also put them together, the primes and twin primes. And as you see here again, I want you to note here that obviously there are a lot less twin primes than there are primes. So the 19th prime is, for example, 67, the 19th twin prime is 109. So they get bigger a lot faster. Yes?
In last page you said we cannot prove
there are infinitely.
Right. If there is infinite number, how can we say we cannot prove? It must be.
Yeah, because that's a conjecture. You have to mathematically prove it like Euclid proved by contradiction that you can always produce a prime. That's right.
Number,
that's right.
You can't be sure.
You cannot be sure here. There is no proof. There's no mathematical. Mathematical proof means it's independent of numbers and stuff. Okay. So that means that you can always prove that there is another pair out there that is bigger than the pair that you know of.
But we don't know.
You don't know. You just guess that, yeah, it makes sense. There should be. Okay? But you cannot mathematically prove it. But you see, advances in mathematics are because of this, because people prove these things. And as I said, since 2,400 years ago, Euclid's proof by contradiction, which is so simple, okay, we still cannot prove that the twin primes, there are infinitely many twin primes. We only guess. It's a conjecture. Okay, that's all. And you know, that's what I want the audience to see is the complexity of this mathematics. Okay, how elementary things are. Factorization, finding out if a number, or just looking at it, if is it a prime or not. Okay, all of those things. But there are no equations that you plug in things and presto, something comes in and say, yeah, this is a prime. That's why I asked, I said, no one knows 1143rd prime, for example, until you go ahead and generate all those primes. Okay? That is the complexity of this mathematics. And that's what I want everybody to appreciate. Okay, so what is a twin prime companion? Some of these stuff are very, and as a matter of fact, this is what we actually coined this phrase at the very beginning. Okay, it was about 14, 15 years ago. But anyway, now it's on the web. So a twin prime companion, or TPC for short, is a composite number sandwiched between a twin prime pair. And so, for example, 4, 102, 3, 3, 7, 6, 8 are TPCs because they're sandwiched between 3 and 5, 101 and 102, 33767 and 33769 respectively. And note that all TPCs except for 4 are divisible by 6, and they all end up with either 0, 2, or 8, except for 4 and 6. Okay. So here, again, you tabulate them, but these indices also, they also follow the same indices of twin primes, because this number is always sandwiched between a pair of twin primes. So the 19th one is 282, and the 521st is 33768. Okay? All right. So again, continues what are TPCs? It's I'm sorry. These are twin TPCs now. So we're going to make it more complicated. We're looking for TPCs that are only differ by 6. So now let's see now. 6 and 12 is a pair. 12 and 18 is a pair. 1482, 1488 is a pair. 19422 and 19428 are twin prime TPCs, or twin TPCs. So note that all twin TPCs except for 6 and 12 are end up either with 2 and 8, because 0 is gone now. So now this is the table. Now I want you to appreciate here how fast they grow, because the numbers are a lot less than the primes or composites for that matter, okay? Or other things. But anyway, the 19th prime is 67, but look at the 19th twin TPC, 19,422, 19,430. Okay. They grow very, very fast. Okay, so they are rarefied at very large indices. They are a lot less than. Look, for example, look between 16 and 17. Index 16 and 17. They're almost 2,000. So you got to go through 2,000 numbers, 16,000 and 18,000. So you search for in 2,000 numbers, and only one pair is this. Then the next one comes at 18,000. Okay. But look here now. You see there are no rules here. Look here. 16 and 17, the gap is 2,000. 18 and 19, the gap is about 500. Okay? So there's no rule. Okay. So what are lonely primes? Lonely primes are primes that are generated when we remove all twin primes from the set of prime numbers. For example, 237, 1187, 9619 are lonely primes. So note that these primes are referred to as isolated primes on Wikipedia. Okay? This is when we remove all the twin primes, then what you're left are these lonely primes. Okay. And now, I tabulate them again. There's no way to do that except for tabulation and running the program. So you can generate these things. 1/14 is 1187. and 790th is 9619. Okay? So, positional additive primes. These are primes that are generated by adding its index to itself. If you do that and it becomes a prime, then you have a positional additive prime. Like for example, 4 plus 17, the fourth prime is 7. 4 plus 7 is equal to 11, so that's the positional additive prime. And so we go ahead and again, we have to tabulate this, and we have to write a program to generate these numbers. So here you see, for example, the 8th such number is 26 plus 101, which is 127. And the 19th one is 98 prime plus itself, which is 521, and that's 619. Okay. All right. So, group properties. Permutation group properties of indistinct objects, such as whole numbers, would result in n factorial. That exclamation mark means n factorial. And I tell you what n factorial is in a minute. N-digit numbers. For n equal 4, then we have 24 4-digit numbers. And n factorial means 1 times 2 times 3 times 4, which is 24. Okay? So, this group property can be studied, and sometimes it seems to have connections with the prime number and the indices. So we demonstrate this relation with a specific number, 9127, after the break, because that's actually germane to a discussion about the mathematics of the Quran that has this generated actually. Okay, so example of permutation group property, for example, 1279. So you can write them down here, and so you can do this by hand basically. Okay, 1279, 1297. If you don't make a mistake, then you check and you see 1, 2, 7, 9, 10, 11, 12, 13, 15, 19, and 24. They're all prime numbers. So I highlighted all of these primes in there, and there are 11 of them in red. Okay. All right. So there's another permutation group, 2, 3, 4, 6, and 2, 3, 4, 6 is again you can do it the same way. Okay. And so I highlighted the first one and the 19th one. 2, 3, 4, 6, and 6, 6, 3, 2, 4. I'm sorry, 6, 2, 3, 4. Okay, so you can. The 114th prime number is 619, and the 619th prime is 4, 5, 6, 7. It's a very simple number. Okay, there are 4 consecutive digits. So if you do that, if you write this permutation group property, the first one is 4, 5, 6, 7. The 19th one is 7, 4, 5, 6. All right. So, what are Mersenne primes? So, when every once in a while you hear that a new prime number was discovered, okay, and you see that that Mersenne primes are in the form of 2 to the p minus 1, where p, this exponent p, is a prime number. Okay. So the list of some of the known Mersenne primes with their positional index is done here. So what I put here in this table, you can actually look at the wiki page and just type Mersenne prime in Google search. It goes to the wiki page for this, and you can see all of these numbers in there. Okay, the associated numbers. I didn't put the numbers because the numbers are very big. Okay, so the first one is 2. The exponent is 2. That means 2 to the 2, which is 4 minus 1 is 3. So 3 is the first Mersenne prime. But they grow very, very fast. And now. But note, you see the complexity of these, okay? Not every p as an exponent, every prime as an exponent, will yield a Mersenne prime. Because see, look, the 4 and 5, okay, the 4th and 5th Mersenne prime. The exponent of the 4th Mersenne prime is 7. The exponent of the 5th Mersenne prime is 13, not 11. So that means that if you multiply 2 by itself 11 times and subtract 1 from it, you are not going to get a Mersenne prime. You're going to get a composite, okay? So the next one is 13, and then the 19th one, you see they grow very, very fast. The 19th one, the exponent is 4,253. And that means that you multiply 2 by itself 4,253 times, and then you get a number which is 1,281 digits. That's how big the number is. So I put this from the wiki page. It starts with 19079, and then it ends up with 91 at the end. Okay? So that's and then I put dot here because obviously I can't write 1,281 digits. Okay, so So anyway, but note here that this was actually discovered in 1961. Okay, it's 51 years ago. So it had to wait for modern computers to be discovered. Okay? So Gaussian primes are prime numbers that cannot be even factored out in complex plane. Okay, so complex numbers like 4 plus I times 4 minus I is equal to 17, and I is the square root of -1. So all of these, you know, the new technology that we have and everything, quantum mechanics and everything, you cannot do it without imaginary numbers. You have to have imaginary numbers. Okay, relativity, everything, you have to have imaginary numbers. So the real Gaussian primes are 3, 7, 11, and 19, and then of the form 4n plus 3, including if n is equal to 0. Okay, so 4n plus 3 is when n is any integer including 0. So again, we have to tabulate these primes. Okay, we can't just guess at it. Okay, so here we tabulate them, and this is the index of the prime number itself, and that's the Gaussian prime. Okay, so these, as you see again, there are a lot less Gaussian primes than there are prime numbers. So for example, 19 is 36, but the 19th Gaussian prime is 67. Okay. And then you have Sophie Germain prime, and there are a lot of these things that, as I say, are somehow they generate the scripture called the Quran. And I'm just mentioning these because, and I can't go through the whole thing. So what I will do is I'll just show you a set of highlights after the break. So Sophie Germain primes are type that if you multiply the prime by 2, then add 1, you get another prime. And so, so for example, 3 times 2 plus 1 is equal to 7. So that's a Sophie Germain prime. So, and again, you can tabulate these. And it's interesting because some of these Sophie Germain primes, they have the same indices as twin primes. For example, the 19th Sophie Germain prime is 281. And the 19th pair of twin primes is also 281, 283. The same with 22nd one, okay, is 419 and 421, and this one is 22nd, is 419. So it's interesting. So when we look at these things, there are all of these relations come into play. So semi-primes, what are semi-primes? Semi-primes in mathematics, semi-prime, also called biprime or two almost prime or PQ number, is a natural number that is the product of two not necessarily distinct prime numbers. So this is called RSA factoring challenge. Listen to this. This is Rivas, Shamir, and Edelman. And factoring challenge that RSA security, this is for banking security and coding of unmanned vehicles and things like that. Okay, so that's how you use it, because you don't want anybody to break into that. Because when you communicate, for example, with a UAV, okay, or some kind of missile or something, you don't want anybody else to know that. Okay, so this is how you try to code these things so nobody else can do this. So the factoring challenge, RSA security offered prizes for factoring a specific large semi-primes, and several prizes were awarded. The most recent such challenge was closed in 2007. So since then there was none. Okay. So now look at this Arecibo message. The Arecibo, this is how we code it. Okay, so this is a matrix of this thing. Okay, so this is a flat sheet, and it's digitized. Okay, just like your TV screen. Your TV screen is a digitized screen, and so what it has pixels. Okay, and those pixels, then you can put colors in there and things, and then all of a sudden you have an image. And the more of those pixels you have, the more definition you have to your picture. So this high def stuff, they keep talking about HD, like for example, this projector is HD. That's a high def of this computer, the screen is HD. So that means that it has a lot of pixels. So those pixels, they actually, the number of pixels, the more pixels you have, the more definition you have to the picture. So this is a very coarse screen here. Okay, so it has 23 times 73. So that's a biprime or PQ number, which is this is a prime number and that's a prime number. So 23 pixels here, and I'm sorry, 23 in the horizontal and 73 in the vertical. And so what you do is you send a message. Well, hopefully, if there are intelligent beings out there, they understand prime numbers. It's a universal language, okay? And they understand semi-primes. So they understand these things so they can decipher this. And now, as you see here at the very bottom, we have the Arecibo telescope. The lights come in here, and they all bounce back on the focal plane, or focal point of that thing. So that's a telescope. And so then we are telling those guys where we come from. We said we come from this solar system. This is the sun. That's Mercury, Venus, and that's Earth. You either bumped up Earth to say that we are here. And the man is right sitting on the Earth, okay? So that's the man. And then Mars, Jupiter, Saturn, and so on, okay? At that time, Pluto was not retired as a planet, so they put Pluto there. Okay? Now if they send one, they will not put Pluto there because now we have 8 planets. Okay. Anyway, so this is the message it was sent. Okay, this message was targeted M13, cluster M13, which is 25,000 light years away from us. Okay, that means it's going to take 25,000 years for this message to get there. It hasn't. Look, it's been going for what? Since 1974. Okay, so only 36 years ago. So it's still here somewhere. Okay.
Right around.
That's right. So it's not. It hasn't gone very far. Okay. As a matter of fact, the farthest object that we've sent is Voyager 1, and it's gone only 16 light hours. Okay, and it was launched in 1974, I believe. I'm not sure, but anyway, that's the farthest object. Okay.
Very stark.
It's mind-boggling. Okay, but anyway, as you see, as I said, this is what the graphic looks like. And then you have the elements 1 through 10. That's 1, and then you have the atomic number of the elements: hydrogen, carbon, nitrogen, oxygen, and so on, and the DNA, and formulas for sugar and bases of the nucleotide of DNA, and all of these things. Okay, so you're trying to tell other people how we're here. Okay, so okay. So some semi-primes, again, we don't know what semi-primes are, so as a function of their indices. So again, we have to tabulate them and write a program to do this. So you find out, for example, the 19th one is 55, 27th one is 82, and 30th one is 87. Okay. All right. So this is another one, triprimes. Now triprimes from Wolfram, if you go to the web, you find this out. Just type in triprimes in the Google search, and you see that they can be factored in 3 primes. Okay, so that means that is 2 times 2 times 11. For example, 44 is a triprime. 102 is a triprime. 2 times 3 times 17. Okay. Now remember, that one was a two-dimensional panel. Now this you can think of it as a 3-dimensional object, and if you try to code this, you can actually build a 3-dimensional image in there. And it becomes a lot more difficult to decipher this code because now you have to find out all of those prime components. You see, it's an order of magnitude more difficult than the biprimes because you're not finished. Once you find one of them, now you're at the level of biprime, then you find the other one, then you can solve it, and then you have to decipher that code. Okay? Okay. And number bases. These number bases were used to binary numbers, for example, because of computers. Okay? And that's not very old. Okay? So they started with the invention of computers, and so binary numbers have only 0 and 1. And so we use that for electronic computers because a wire either had current in it or it didn't. If it had an electric current in it, it was 1. And if it didn't have, it was null, then it was 0. So with those wires, as many you have, in the old computers, they had these wire wraps. And if you look at, for example, moon machines from the 60s, that's what they did. Okay? They actually made these wire wraps because they didn't have electronic chips. Okay? Later on, they had electronic chips, so the things became a lot smaller. But that's how it was. So all of those were programmed through those wire wraps. And if they made a mistake in those wire wraps, then they were in trouble. So they had to go through it. It was very difficult to find it. So it wasn't easy. Okay. So anyway, for example, octal base, you've heard of octal base, is 0 to 7. So you can, for example, write a number. Okay. You can write a number, for example, 114. Okay. And to us, because we work with decimal, we always say, oh, 114 means 114. Okay. However, if somebody is actually used to octal, 114 for that person doesn't mean 114. It means actually 76. Okay? So you have to figure out what base number that person, so it's communications, you see. So a lot of things that happen is because of lack of communications. People don't want to hear your side. Okay? They don't want to hear your argument. They don't want to hear your point of view. They just think that they are right. Now, when that person says 114, 114, and you demand $114 from that person is working in octal, for him or for her is only $76. It gives you 76 bucks, you'll be probably mad. But it's just lack of communications. Okay? So that's most of the problem stuff. How this actually generates the parameters of the Quran. Okay? All right. Okay. So the material value of Arabic alphabet. Okay, Arabic alphabet, just like Hebrew starts at 400 because there are only 22 letters in Hebrew alphabet. In Arabic alphabet, there are 28, and they all have a gematria value associated with it. So it's like alpha, beta, gamma, delta. Okay, Latin is the same way. So you have 1, 2, 3, 4, up to 9. I'm sorry, up to 10, and then after that it goes 10, 20, 30, 40, up to 90, and then it goes 100. 200, 300, up to 1,000. Okay? So what happens is that basically every written word would have a value. Okay? Gematria value corresponding to it. Okay. Like for example, there are some of the names that people could be familiar with, and they have gematria value of Adam, for example, is 46. Jesus is 150 in Arabic. Muhammad is 92. Moses is 116, and Noah is 64. Okay, so this is the map. Okay, so I'm going to stop here and have a break for 10-15 minutes, and then we'll come back and we'll see the rest of this, how this actually generates the parameters of the Quran. Okay. Okay. Welcome back, everybody. And so now the first half of the talk that I explained. All of those mathematical relations about primes and the indices and number bases and group structure of numbers. Now I want to present to you this ultimate mathematics and how this mathematical composition that we had actually generates the Quran or the parameters of the Quran. Okay, so and it is a 19-based mathematical sort of structure that involves primes, composite, twin prime companions, and the indices, and that's what they discuss in the first half of this talk. And really the only hint that we have is chapter 74, verse 30. It said over it is 19. That's the whole verse. Over it is 19, and this is the only place that number 19 actually is mentioned in the entire Quran. So the mathematics encompasses primes, twin primes, positional additives, subtractive primes, composites, group theory, extensive relation among the indices of primes and composite and twin primes, etc. And we study all of these and see how they actually generate the parameters of the prime. So this math is beyond human knowledge, as I described at the beginning of the previous part of the lecture. So. Quran and introduction. The Quran was revealed on the 27th of Ramadan, which is the 9th month of the Hijri calendar, and is 600 AD to Prophet Muhammad. And every chapter or surah, as it's called, in the Quran starts with a statement in the name of God, the All-Gracious, the All-Merciful, which is the opening statement of the Quran, except for surah chapter 9. Surah 27 contains two such statements. So what it does actually, then the total frequency of the occurrence of the opening statement is therefore 114, which is the number of chapters or the surahs in the Quran. So, an introduction to the Quran. Okay, a unique aspect of the Quran, never seen in any other literary book, is that there are 29 of chapters or surahs are prefixed with some initials, Quranic initials that was referred to as by Rashad Khalifa, and this book which was published in 1981. Okay, and so he coined the phrase initialed Quranic initials. And so those chapters or surahs are referred to as initial surahs. Okay, there are 29 of them out of 114. So, Quran parameters, there are 114 chapters or surah, 6,234 numbered verses, 6,346 total verses, 29 initial chapters. Surah 42 has 2 sets of initials. That's very unique. Chapter 42 in the Quran has 2 sets of initials. And obviously 85 uninitial chapters. So the total number of word God, which is mentioned in the Quran, is 2,698. All of these parameters are based on the fact that chapter 9 has 127 verses. And we will see how this mathematically described actually generates 9 having 127 verses. Okay, so this is the revelation and compilation of the chapters or surahs in the Quran. It's kind of difficult to read this slide. But anyway, the first chapter that was revealed is 96, and the last chapter that was revealed is 110. Okay? So the compilation and revelation order are different. Okay? And then you can break this down into initial chapters. So these are the revelation of the initial chapters in the Quran. And so the first chapter that was revealed is 68. The first initial chapter was revealed is 68, chapter 68. And it's interesting because the way it starts, 96 is called the embryo. That's the name of the chapter. And it actually, the first verse, the first number verse in there, it actually starts read. Okay? And this chapter, chapter 68, which is the second chapter that was revealed by the first initial chapter, is actually called the pen. Okay? So it's literature that actually God is stressing and advocating. Okay, read and write. Okay, so anyway, so as you see here, for example, the 19th initial chapter that was revealed is 43. Chapter 43 is the 19th initial chapter, and so on. Okay, the last initial chapter that was revealed is chapter 13, which is called the Thunder. All right. So these are the integer numbers in the Quran in ascending order. Okay. So, you know, a lot of times you hear about these 72, number 72. Okay? 72 virgins in heaven. Okay? And as you see, number 72 is not even mentioned in the Quran, in any context. Okay? Unfortunately, that's how people think, okay, of the Quran. But as you see, number 70 is not even in the Quran. In any context. Okay? So these are man-made stuff that people have made, and they are broadcasting these things and putting really the wrong opinion and the wrong impression on masses of people, and they do not search for themselves to see what the truth is, and so they keep, you know, sort of propagating error. Okay? So, but as you see here, as I said, that number is not even in the Quran. So there are altogether, there are 30 integers in the Quran. Okay? So the smallest one is 1, and the largest one is 100,000. Okay. Now, if you add also the fractions in the Quran, there are 8 fractions in the Quran. And those 8 fractions, if you add those to the numbers, there are 38 numbers in the Quran. Okay? These are without repetition, by the way. All right. So, and as I said, sequential and gematria value of the Arabic alphabet, I wrote them down here. There are 28 Arabic alphabet, and these are the gematria values. And now, I'm going to start with this lonely primes, okay, and see how this table actually is going to tell you about the parameters of the Quran. Okay. Here, So remember now, 790th lonely prime is 9619. And now let's go to the next page and I describe it to you. Okay. 1187 prime is 9619, and the first chapter that was revealed, 96, has 19 verses. However, 1187 is the 114th lonely prime, and the Quran has 114 chapters or surahs. Okay? So you see, it connects the number of chapters in the Quran to chapter 96, which was the first chapter that was revealed, having 19 verses. Now, furthermore, 9619 is the 790th lonely prime, and 790 base 19 is equal to 2698 in base 10. But 2698 is the number of times the word God has been mentioned in the entire Quran. Okay? So that table, actually, those numbers, they generate these parameters of the Quran. Now look at this. Okay? So when the first chapter, which was 96, revealed with 19 verses, it actually was telling us that there are going to be 114 chapters total, and the number of times that the name of its author is mentioned in the entire book is going to be 2,698 times. Okay. We also have this table, prime and composites. Remember I said I'm going to show this so I can tell you that there are a lot less primes than composites. Okay, well look at the 19th one. Over it is 19. The 19th one happens to be, the 19th prime is 67 and the 19th composite is 30, but chapter 67 in the Quran has 30 verses. Twin prime pairs. So we tabulate the twin prime pairs. Let's look at the 114th one. That's the number of chapters in the Quran. Is 4271. And we'll go to the next slide. And I'm going to write all of the permutation of 1, 2, 4, 7. And this is what we'll see. And all of the prime number ones are highlighted in blue. Those are prime number ones. And the one in violet here, okay, or purple, is 2147 and 4712. These are the ones that are divisible by 19, 7 and 17. And look now what happens. Okay. There are the seventh group element is 2147, which is 113 times 19, is the total frequency of the HM or Hamim in the 7 HM initial chapters in the Quran, which is 42, 46. Okay? There are 7 of them, and that's the seventh element, 2147. That happens to be the total number of frequency of those in those 7 initial chapters. Note that 7 of these group elements are also prime, highlighted in blue. Okay. So, then the other group elements divisible by 19 is the 17th element, which is 4712, and 2147 plus 4712 is equal to 6859, which is 19 times 19 times 19. Okay. The 19th group element is 7124, and its index its index is 6211. Chapter 62 in the Quran has 11 verses. 71, chapter 71, verse 24, which is the 19th group element of that table, is the 2698th verse in the uninitial chapters in the Quran, and 2698 is the number of frequency of the word God in the entire Quran. Now, chapter 42, remember, has the only chapter in the Quran that has 2 sets of initials, not just one. 42.1 and 42.2. Hamim, Ain Sin Qaf, or HMASQ. Okay? Now, the number of verses from 1.1 to 42.1 is exactly 4,271 verses. Okay? And now remember now that 4271 is the 114th twin prime, which is the number of chapters in the Quran. Okay? The number of frequency of HM in chapter 42 is actually 353, and that happens to be the 71st prime number, so we are back to 4271. Surah 71 happens to be the 42nd uninitial chapter in the Quran, and the index of 42 is 28, and chapter 71 actually has 28 verses. 9124, which was the 19th permutation of 1247, happens to be 1824th revealed verse in the uninitial chapters. And 1824 is equal to 9619, 96 times 19, but chapter 96 has 19 verses. The digits of 1, 8, and 2, 4 are the indices of prime number 2, 19, 3, and 7. The first prime number is 2, the 8th prime is 19, the third prime, the third prime is, number 3 is index is 2, and the fourth prime is 7. Okay? And these numbers, 2 times 3 times 7 times 90 is 798. 790 is the sum of the frequency of the initials Kaf, Ya, Ain, Sad. I put it here, I spelled it out here, in chapter 19. Okay? So you see those 4 digits, 1, 2, 4, 7, gives you so much information about the structure of the Quran. All right. Now, position of adjective prime. Remember I showed you this table here. And now let's concentrate on 1998, 521, 619, and 114, and these 2 lines here. And I go to the next slide and I describe it to you. I just grab those 2 lines, 1998, 521, and 619. Immediately you see Surah 99, chapter 19 has 98 verses. Note that 619 happens to be the 114th prime number, you see, corresponding to 19 over this 19, and 114 is the number of surahs or chapters in the Quran. Rank 114, the number that this one, surah is the chapter in the Quran which is corresponds to the 808th prime plus its prime, which is 6211, and chapter 62 has 11 verses. Furthermore, 521 times 19 is 9899 is the frequency of initial A plus L plus M, or Alif Lam Mim, in the first initial surah, which is chapter 2. So you see, line 19 gives us so much information about the structure of the Quran. Okay, now we look at these twin prime companions, and I want to look at this one here, 521st one, and look what happens. The 521st TPC is 33768. The number 3368 is a concatenation of a prime and its index. In other words, 68th prime is 337. Note that 521 is associated with the count of initials in chapter 1 because 521 times 19 will give you 9899. Okay. Initial surah, and 68 happens to be the last initial chapter in the Quran. So this corresponds to the first one, the first initial chapter, this corresponds to the last initial chapter. So it turns out that 2 permutations of 1, 2, 5 are 1, 2, and 5 are 251 and 521. They're both primes, and their indices happens to be 54 and 98. And 54 and 98 is actually equal to 152, which is 8 times 19. But remember now, 8th prime number is number 19. But look over here. Remember 337 and 68? Okay, let's see how they're connected. We also know that 337 in base 10 is equal to 521 in base 8. Remember that communications I was telling you about? Okay, we have to listen to people to see their point of view. Okay. All right. So the number of verses from 1-1 to 1998 are 2,346. But 1990 is the index of composite 2346. And chapter 19 has 98 verses. 2346 can be actually factored out into 23 times 2 times 3 times 17. Remember I said this is one of those composites that they can be factored out into primes? Okay. The indices of these prime factors are 9, 1, 2, 7. And this was a friend of mine, Milan Sok, that noted this first. Okay. And you write the permutation of these one, and you notice that the 19th group element is 9127, and chapter 9 actually has 127 verses. Okay. So, now remember that I said something about that sometimes you see relations between these tables, permutation table, and the primes. So it turns out that there are 11 group elements that are prime in that table that I just showed you. I highlight them in red. And the 11th prime happens to be 31, but 1131st prime is the 19th group element, which is 9127. In other words, 1131st prime is 9127. But that comes from the number 11, which is the number of actual number of prime numbers in that permutation group structure. So note that the digital sum of these 4 digits also add up to 19. 9 plus 1 plus 2 plus 7 is 19. All right. From 1-1 to 9127, there are 1,362 verses in the Quran. And the index of composite 1362 is actually 1143. So in other words, 1143rd composite is 1362. But 1143 is 9 times 127. See, from 1-1 to 9127, back to 9127. So again, this is Milan's private communication. And now, look at this. Permutation group property of 2, 3, 4, 6. Permutation group property of 4 digits, 2, 3, 4, 6. So you write them down, it yields 24 4-digit numbers. And so the first one is 2, 3, 4, 6, which is the number of verses from 1-1 from the beginning of the Quran until the end of chapter 19. Okay, over it is 19. The 19th group element happens to be 6, 2, 3, 4. 6, 2, 3, 4 is the total number of verses in the Quran. Okay? So you can think of it this way. Which one generated which one? Okay? The fact that the Quran has 6, 2, 3, 4 generates the other fact that the number of verses from 1-1 to 1998 is supposed to be 2, 3, 4, 6, or that one generates actually the total number of verses in the Quran. Okay? So you see the interlink here? All right. So here I said it's generators. The 19th group element 6234 is the total number of verses in the Quran. 6234 also tells us that chapter 62 is the 34th uninitial chapter in the Quran. So you see, when you see those either when I showed the order of where they are in the Quran, in the compilation and revelation, for both the initial chapter or uninitial chapter and total, there's a reason for that. Okay, they are not there just by accident. Chapter 62 is not the 34th uninitial chapter in the Quran by accident. It's because of this, because this 19th permutation of 6234 or 2346. Okay, so now look at this. 6,234th prime number is 62011, and chapter 62 has 11 verses. Okay. All right. And let's look at this one. The 114th prime is 619. We know that already. But the 619th prime is 4, 5, 6, 7. It's a very easy number. There are 4 consecutive digits. Okay. Now let's look at the permutation group property of this. 4, 5, 6, 7, 4, 5, 7, 6, and you generate it, and you come up with the 19th one, which is 7456. Now let's look at this. So the 114th prime is 619, and the 619th prime is 456. The Quran has 114 chapters. 19th group element is 7456, and chapter 74 in the Quran has actually 56 verses. Note that chapter 74 is the only chapter where the number 19 is mentioned. Okay? The index of composite 7456 is actually 6512, and chapter 65 has 12 verses. Number 19 is mentioned in verse 30 of chapter 74, as we showed in that previous slide, and 30 happens to be the 19th composite. So this directly connects the number 19 to the number of chapters in the Quran. Okay. Now let's look at this. Remember now? Okay, that big number that was generated in 1961. Okay? Now everything that I'm going to tell you here would have been completely meaningless in 1960. Okay? Because this number was not discovered yet. Discovery of this number happened in 1961. So you cannot explain this was when Kennedy was running for president in the United States. Okay? It would be completely meaningless. During World War II, this would be completely meaningless. Okay. Now let's see what happens. Okay. The 19th, exponent of the 19th group element, Mersenne prime is 4253. And now we'll go and see what happens. The 19th Mersenne prime is 4253, its exponent. Chapter 42 has 53 verses. Note that chapter 42 is the only chapter in the Quran that has two sets of initials. So as though God was giving you a hint that you see the reason there is something important about this chapter, it has two sets of initials, not just one. Okay? So, and we see the importance of it. Okay? So you cannot, you could not describe this in 1930 or even 1960. Okay? So, all right. Now we do the same thing. We write the permutation group property of 4253, and then we'll see this table here. And the 19th one is 5234. Okay, so let's see the ones that I highlighted in red, see what the properties are. Okay. All right. All right. The permutation group properties of 4253, which is tells you chapter 42 has 53 verses, the exponent of the 19th Mersenne prime. The group element 19 is actually 5234, and its index is 4537. Okay, so composite 5234 has an index of 4537. Chapter 45 in the Quran has 37 verses. The group element 22 is 5342, and its index is 4635, and chapter 46 in the Quran has 35 verses. So you see, of those HM initial chapters, we already, with this mechanism, we already generated 3 of the 7, okay, the number of verses in those chapters, namely chapter 42, 45, and 46. Now let's go on. The group element number 9 is 3425, and it is the index of composite 3975. Chapter 39 has 75 verses. Note that 39 is the 19th uninitial surah in the Quran. The group element number 10 is 3452, and its index is 2969. And chapter 29 in the Quran has 69 verses. Now we go, it gets a little bit more complicated. Now we go to this 20 PCs and see how they generate these parameters of the Quran. Okay? So, now remember now, there are not too many of these 20 PCs, so as soon as you go to higher indices here, they get extremely big. Okay? Because the gap is so big. Okay. So 20 PC, let's look at line 6. Line 6 corresponds. Index of prime number 13 is 6. Okay. It corresponds to 1482 and 1488. Guess what? The frequency of initial A's plus L plus N plus R in chapter 13 is actually 1482. Look, it's right here. Comes right there. Okay? All right. Now let me also put this into my talk, okay? That there are different spellings of the Quran. Okay? There is only one spelling which is correct according to this, and that's the so-called Hafs Quran. Okay? The Hafs version of the Quran is the only correct one that yields this kind of things, because you can spell it differently, and it's all okay. They're all valid. They're all valid spelling. But this mathematically tells you which one is correct. There are a lot of debates which one is correct. Okay? But this one puts an end to that. It says, aha, this one is the one. This is supposed to be the way it's spelled. Okay? Which is 78 times 19. And note that 78 is 6 times 13. You see that? 6 times 13 will give you actually the coefficient of 19 for this one. However, 78 is also the 19th triprime. Okay, when we talked about the three-dimensional view of some coded message, now the two-dimensional one. Okay. So the 78 is also the 19th triprime. Okay, let's look at line 9. Line 9 corresponds to 3252 and 3258, and 85th and 86 is the index of these TPCs. So these are the twin TPCs. So the digital sum of TPCs indices, 85 and 89, and the twin TPCs, 3252 and 3258, corresponds to 27 and 30. Now look, 8 plus 6 is 14, plus 5 plus 8 is 27. 3 plus 2 plus 5 plus 2 plus 3 plus 2 plus 5 plus 8 is 30, so you are 27, 30. Look at this. Note that Surah 9 does not have the opening statement. 9, and it is compensated at 27:30, chapter 27, verse 30. Remember I said that chapter 27 has two opening statements? In the name of God, the All-Gracious, the All-Merciful. Chapter 27, verse 30, it tells you exactly what it is, what it's supposed to be. It's supposed to be 27:30. Can't be any other place. Okay? And that refers to this letter that Queen of Sheba receives from Solomon, and it is in the name of God, the All-Gracious, the All-Merciful. Okay? So, the indices of composite, the index of composite 3252 is 2793, and chapter 27 has 93 verses. Okay? It happens that 27, chapter 27, is the 9th initial surah that was revealed. All right, Gaussian primes, remember we talked about Gaussian primes. Let's see how this one generates 9 having 127 verses. Okay. Now, look at this line here. Okay, well, first of all, let me look at this one. Okay. The 10th prime number is 19 and is 67. It happens that the 10th initial surah in the Quran is number 19. The 19th initial surah happens to be 36. Okay. The 47th Gaussian prime corresponds to the 92nd actual prime. It happens that 47, remember I showed all of those geometric value of those people that you may know. Muhammad happens to be 92. Chapter 47 in the Quran is actually called Muhammad. Okay. So when you see those names for those chapters, they are not by accident. They were supposed to be called that because of these tables that I'm showing you. So these things are generating the Quran. Now you got to ask yourself this, okay? Are the numbers older or this universe? The numbers are older than this universe because the number existed before this universe was here. They are independent of this universe. Okay? So here, when we go to 764, 1514, look what happens here. 764 is 2 times 2 times 191. It's a triprime. Okay? And the indices of these is 1, 1, 4, 3. But remember, 11, 4, this is 9 times 127. And that was the index of 1362, which was the number of verses from 1, 1 to 9, 127. Okay? But 1514 happens to be the 1273rd composite. 1273 being equal to 19 times 67 is the number of word God from 1, 1 to 9, 127. Okay? Now look at this. I talked about the triprimes. The 44 is the 9th triprime. Now let's see how it's connected to chapter 9. Okay? If you write all of the hameems in chapter 44, you notice this 44 has 150 memes or m and 16 ha's. Okay? And then the sum is 166. Let's look at the indices of this composite. 29, 114, 9, 127. Okay? Now let's see what the importance of these numbers are. There are 29 initial surahs in the Quran. There are 114 total surahs. Chapter 9 has 127 verses. Okay? The reason is because the 9th triprime is 44. That's why that chapter generates these. Okay? All right. Now let's look at natural laws. Okay? Natural laws are the laws that we're supposed to follow. If you do not follow God's natural laws, we are going to be in trouble. Okay? And so this universe was created based on natural laws. And the natural laws tells you, for example, what's supposed to be the abundances of different elements in different things. Okay? So here I'm gonna just put here Earth, Earth crust, and Earth atmosphere. And so the thing that's sort of hard to read at the bottom is the link for this table that I got it from. Okay. Universe is mostly made of hydrogen. Okay. Earth is mostly made of oxygen. You see that? Oxygen is the most. Hardly has any hydrogen in it. See, look over here. Okay. It hardly has any oxygen, any hydrogen in it. Okay. So anyway, so it's mostly made of hydrogen, and the sun is mostly made of hydrogen, 91%. Okay. Humans are mostly in our hydrogen, 61% hydrogen, because we're mostly water. Okay? So if you look at this table at the bottom, we have more in common with the stars than we have with our Earth. Sort of we were sent to exile or something. Okay? But you look at this. This is interesting. Okay? So now we look at these guys here, O, C, and N. Okay? O, C, and N, or C and O, are the elements of life, okay? And so we'll see here that O, C, and N are the most abundant in humans because that's how the DNA is constructed, from C and O. Carbon, nitrogen, oxygen, okay? And they happen to be, now I'll show you this, okay? This is our own paper that we had in the International Conference of Cosmic Ray Physics, and that was in Tsukuba, Japan in 2003. And now look at this. This is what you measure with cosmic ray, with balloon experiments. So you send balloons to about 36 kilometers above the Earth, and at that place is basically vacuum. So you have a few grams of air there, but it's for all practical purposes vacuum. And so what you actually measure is the primary cosmic rays that come from all over the universe. And so these nuclei are easy to detect with balloon and satellite experiments. So that would be had a balloon. And so mostly again is hydrogen in the universe, and then helium, and then a little bit of lithium. But now look over here. After the hydrogen and helium, the most abundant elements are C and O in the cosmic rays. Okay? And look at a plant. This is a chemical composition of plants. Chemical composition of plants, look at it. Okay? Hydrogen, carbon, nitrogen, oxygen. Okay? Which tells you that when the universe was created, life was supposed to be an essential component of this universe, and it's abundant because that's the abundance of elements that actually corresponds to elements of life. Okay? So you see, look at this. It's hydrogen and oxygen. So when people actually look for life, they said, look for water. Follow the water and you'll find life. Okay, so every place you go, they try to find water. Okay, you go to Mars, they're trying to find water on Mars. Okay, so now look here. Oxygen is so prominent here and so abundant. Look at hydrogen. That means there's a lot of water in the universe. And now look at that. C is almost the same as oxygen, okay? Which means that carbon-based units or living organism based on C and O must be abundant. So the initial moment of creation, okay, life was supposed to be a huge component of
Can I ask you a question?
Yes?
Are you telling C and O or
C N O.
and nitrogen?
C N O. Carbon, nitrogen, oxygen.
Yeah.
Yes. That sort of sounds like C N O. Yeah,
I know, that's why.
No,
But
it's
I knew
C
it was-
N O. Yes.
Yeah.
Yeah, it's carbon, nitrogen, oxygen. And anyway, okay. Okay, and then this is the table of elements. Now look at this. This is so fascinating. Okay, the fascination that I have with this one is based on counting. It's simple counting. When you actually count, you generate elements. Okay, which actually becomes very, very easy to teach it to a 2-year-old. Okay, but unfortunately we don't teach table of elements to 2-year-olds. We wait until they're teenagers. and then we try to ram them down the throat, and then it becomes boring to them, and they don't want to learn. But if you tell them that, yeah, there is another language besides English or whatever your mother tongue is, and that's called physics and chemistry. And physics and chemistry, one is called hydrogen, okay? Two is called helium. Before you know, that kid can count to 20, 30, 40, okay? In the physics and chemistry. So by the time he's a teenager or she's a teenager, she's okay. Okay? So, but we try to ram them down into, push it into their heads, okay? At that age of 16, then physics and chemistry becomes a really boring subject. They don't want to learn it anymore, okay? So you only have a few physicists and mostly lawyers, okay? That's the problem, okay? So here, if you show them how to count, if you taught them, if you teach them how to count at that age, they all learn, okay? So it's very easy. Okay, so, but the importance of it is that simple counting actually generates nature, okay? These are not prime numbers. These are just simple stuff, okay? Then can you imagine what I described there that actually generated the Quran, how important it is to actually follow the scripture, okay? And now, let me just say this, okay? That not only this mathematics actually validates the Quran, it actually validates the stories in other scriptures. When they say there was a flood at the time of Noah, it's mathematically coded in the Quran, so that means that story was correct in the Old Testament. You see? When Jesus healed the lepers in the Bible, it says the same thing in the Quran, but now this time it's mathematically coded because you and I didn't see it. We were not present at that time when Jesus did that. So we just have to hear it and sort of accept it on faith. But now God gives you a reason why it was true. And that reason is beyond human capability. Alright, so the balance or the equilibrium, okay, now is the natural law. And this is really the intricacy of this system that comes in. Everything that we can describe within mathematics that describes the physical universe is based on equations. And equations mean that one side is exactly equal to the other side. Okay? That's a very delicate balance that one has to maintain. Okay? So here I put free fall in vacuum, acceleration equal to minus gravity, minus g of gravity, and velocity and displacement. Everything is based. So you cannot disturb this side, have to be exactly equal. Okay. Now, the same thing with the entire universe. Newton's law is F equal to G M, capital M, little m, divided by R squared. That's the force that every two objects in the universe, they exert on each other. They are equal and opposite, okay? So the sun attracts the earth attracts the sun, but the amount of force that they exert on each other is exactly equal. Okay? It's not unequal. Just because the sun is bigger, that doesn't mean that the sun can aggress against the earth and disturb the balance. They don't. Okay? We do that. Humans do that. If humans are bigger, they become bullies. Okay? They try to actually impose their will on somebody else. Okay? So what we do, we disturb the balance. And then you see the consequences of that. And the consequences are great because God will we re-establish the balance, and that re-establishment of balance is the suffering that we have after that, because we disturb the balance. These are natural laws. Okay? So here we go, even concept of antimatter. Okay? So we can describe it in the relativistic notion of this. Okay? So, but we see that the minus sign here, actually, which has come from algebra, tells you that is the consequence of algebra, signifying that C of negative energy of antimatter. Dirac came from this idea, came up by, with this idea a long time ago, okay, 1930s. But anyway, so table of periodic table, you see, if I multiply those numbers by -1, I generate all the antimatters. Okay? So because the antimatter means that proton has negative charge and electron has positive charge. So you have antiproton and an anti-electron with positron. Okay? So an anti-hydrogen would be a proton which has a negative charge, it's called antiproton, and a positron going around it just like us. Okay? So And so you can immediately do that by a simple multiplication. So you know the operation. The operation is simple multiplication by a minus sign. So you generate all of these guys. But you still count. But you count in negative. You say minus 1, minus 2, minus 3, and so on. Okay?
Can I ask a question?
Yes?
Is anti-matter
All right.
the
So no. I have some verses here from the scriptures. Okay. So these are some of the verses in the scripture. Okay. So maybe somebody can read this. Okay. This is. Go ahead and read it. Somebody. Do you want to read it, please? Yeah.
24:19. When you are harvesting in your field and you overlook a sheaf, do not go back to get it. Leave it for the alien, the fatherless, and the widow, so that the Lord your God may bless you in all the work of your hands. When you beat the olives from your trees, do not go over the branches a second time. Leave what remains for the alien, the fatherless, and the widow. When you harvest the grapes in your vineyard, do not go over the vines again. Leave what remains for the alien, the fatherless, and the widow.
Okay, now we go to the next. Now we go to the next slide. Okay, and we have more scripture to read, and so we read it. Okay. Here you go. Go ahead and read it, please.
6:2. So when you give to the needy, do not announce it with trumpets, as the hypocrites do in the synagogues and on the streets, to be honored by men. I tell you the truth, they have received their reward in full. But when you give to the needy, do not let your left hand know what your right hand is doing, so that your giving may be in secret. Then your initiator, who sees what is done in secret, will reward you.
Okay, now the other slide, we're gonna read from the scripture again, and we'll see here.
2:177. Righteousness is not to turn your faces toward the west or the east. On the contrary, righteous are those who believe in God and the last day, the angels, the scripture, and the prophets, and they give their money in spite of loving it to the relatives and the fatherless, the poor, the refugees, the beggars, and to free the slaves. And they uphold the contact prayer and give the cleansing charity, and they are faithful to their promise once they make a promise, and they steadfastly persevere in the face of war and loss and during hardship. These are the truthful ones, and these are the God-fearing ones.
I deliberately didn't put any title on this, where these verses are coming from, okay? So you may guess for yourself, okay, where they're coming from, but let me just tell you, okay? And the first one was Deuteronomy 24. That will come from the Old Testament, okay? When you are harvesting in your field and you overlook a sheep, do not go back to get it. Leave it for the alien, the fatherless, and the widow, so that your Lord God may bless you in all the work you have of your hands. And then 20 is when you beat the olives from your trees, do not go over the branches a second time. Leave what remains for the alien, the fatherless, and the widow. And when you harvest the grapes in your vineyard, do not go over the vines again. Leave what remains for the alien, the fatherless, and the widow. Okay. Now look at this one, and then the next one is. This is what Jesus says in Matthew 6. Okay. So this is the New Testament. But look at the similarity between this and the other one. He says, do not let your right hand know, your left hand know what your right hand is doing. It has to be in secret. Now the other one said, leave it over there. You leave it there. The person who picks it up doesn't know who gave it. The person who is given it doesn't know who's picking it up. You see? That's complete lack of prejudice on the part of the person who's given it. Okay? Now let's look at the last one. The last one is the Quran, 2:177. It says that righteousness is not turning your faces towards the east or the west. It's not just prayers. But it says, on the contrary, righteous are those who believe in God, the last day, the angels, the scripture, and the prophets, and they give their money in spite of loving it to the fatherless, to the relatives, to the fatherless, the poor, the refugees, the beggars, and to free the slaves. Okay, so you see the similarity between these. Okay, I mean it's absolutely amazing. But I'm just trying to say that we have to broaden our horizon. We have to listen to the other side. Okay? And so it's very clear from these verses that they're all coming from the same place. They're coming from God. This is what God is advocating. Okay? So let me just conclude here. According to the mathematics introduced in these talks, the Quran and the scriptures in general have always existed beyond the dimension of physical universe in which we live in. Ultimate mathematics took the form of a book called the Quran nearly 1400 solar years ago. Now, as I mentioned, okay, the idea about this is that not only it confirms the history which is narrated in the Quran, okay, the history of Jesus, the history of Moses, the history of Pharaoh, it also confirms what happened in the past. So it's incumbent upon us, okay, to believe in all scriptures. Okay. So ultimate mathematics took the form of a book called the Quran nearly 1400 years ago. It can therefore be concluded that the Quran is a literal embodiment of the ultimate mathematics. It can only be authored by God. So let me just read this one because the unification of message that God has sent. Okay? It says, He decreed for you the same religion that He decreed for Noah, and what we inspired to you is the same as what we decreed to Abraham, Moses, and Jesus. You shall uphold this religion and do not be divided in it. Your call is heavy to bear for those who set up partners for God. God alone is not enough for them. Okay? So they need a partner for God. God chooses for Himself whomever He wills and guides to Himself those who repent. Those who admit that they violated the equilibrium that God has created. That they did not obey natural laws. Okay? So this is what God is saying, that there are not many religions, there are just one religion. And that religion means to be at peace with God. Okay? That's what the meaning of Islam is, to be at peace with God. That's why the Jews, they actually offer shalom, which means peace. That's why Muslims say salam, which means peace. That's why Jesus was called Prince of Peace, because He offered peace. Okay? So these are very interesting things that we have to look into, okay, before we jump to conclusion, and as I said, go with ignorance instead of the facts that are available. And let me also mention this, that our responsibility is much higher because at this age, where literally information is at our fingertip, okay, that we can actually go to Google, for example, and Google some subject, like all of these stuff that I told you, okay, these tables and stuff, you can actually get them from all these Wikipedia or Wolfram Math or whatever, okay, but you can get this information, okay, it's not hidden, okay. So our responsibility is much higher to verify things, and that actually, there's a verse in the Quran, it says that do not accept any information unless you verify. So it's responsible because God has given us the brain, the eyesight, and the hearing, and we are responsible to use our senses. Okay? So everything has to be done in that way. Okay. All right. Well, thank you very much, and I concluded here.